Welcome back, everybody. Up next, we have Gleb Lesnikov, Head of Architecture at Dodo Brands. He will share his knowledge on AI coding in practice, from LLMs to production workflows. Gleb, the floor is yours. Sorry, your mic is turned off.
Yeah. My name is Gleb. Just a second. I will show you the presentation. Okay, this must be it. You see my screen, right? So, yeah, my name is Gleb. My name is Gleb. I am head of architecture in Dodo Brands. I work as an architect from 2020, almost 5 years. Previously, I was in site reliability engineering, infrastructure works. My interests are mostly backend databases, NewsSQL, analytics, what do you call big data, DDD, architecture, microservices, whatever you call. So everything about backend. I work in Dodo Brands from 2015. Yeah, so what is Dodo Brands? As of now, we are a pizza company and a coffee company. We operate in 26 countries, serve 22 million clients, have 380 engineers, and overall in our stores, pizza and coffee shops, works more than 60,000 employees. So our product is digital enabled pizza stores. All the software, almost all the software, like 99.9% of software we write for ourselves, including kiosks, Android and iOS apps, even accounting software, ERP, everything is done through everything we write for ourselves. As this is a Serbian conference, we are actually now also open in Serbia, in Belgrade and Novi Sad. Yeah, so we have 2 pizza stores in Novi Sad and the one in Belgrade. So if you have time and see it somewhere, you can try us. And also we have a coffee startup called Drink It, and it's open now in 3 countries. Sadly, not in Serbia yet, but definitely someday we will open in Serbia also. So yeah, so this is kind of the same. It's a digital coffee shop with incredible iOS and Android applications and digitalized production. So our technology stack is basic. We have TypeScript and React on front end. For mobile, is Swift and Kotlin as usual. For backend, we use .NET and ASP.NET Core, and Kafka and MySQL. For analytics, we use Databricks and Spark. So for infrastructure, usual stack, except I think .NET, but it's also one of the safest choices right now. So before we start, if you want to do a workshop practice, you will have to have GitHub account, access to Copilot free or paid. There is a 30-day trial. You'll have to have Git, Visual Studio Code, .NET 9, and the Context 7 account. There will be a little bit. So I give this information to you so you have some time to prepare. If you wish to use if you wish to do a workshop practice, but you can use your own project if you have, or you could use your own IDE with the GitHub Copilot plugin. There's plugins for everything. Also, if you don't like Copilot, you can try it with any other agent like Claude or I don't know Zencoder, because everything is the same, kind of the same. Yeah, and for GitHub Copilot, one thing you should note and remember that Command I opens inline chat. This is very useful, and Option Command B opens the chat tab, the chat window, this right side window. So there you can also track your premium requests, and so this is basically what GitHub Copilot has. But also, as I said, you can use it with any like Windsurf or Cursor, whatever. They are pretty same right now. One also disclaimer regarding that is that this talk will be old really fast. Like in 3 to 6 months, something will be outdated from it. The models, the interfaces. So this field moves like really fast. So I'm sure like in 3 months the Copilot or something else will be like completely different. So keep that in mind. So what are agents? AI agents are autonomous software tools that perform tasks, make decisions, and interact with their environment intelligently and rationally. They use artificial intelligence to learn, adapt, and take action based on real-time feedback and changing conditions. So AI agents can work on their own or as a part of a bigger system, learning and changed based on the data they process. So this is like a brain or something. With comparing to a chatbot style, or even actually the LLMs that are basis of this AI agent, they are trained on document work. So this is really far from the thing that they have been trained on to respond to generate documents. Like when base models are trained, they're trained on a almost like PDF documents. So the model like gets the document and then should like reply to a document, and this is like the basis of the training. So or how it was like 5 years ago. So right now this is like not like completely different, but this moved pretty far. So what is the difference between these instruments like AI agents, or maybe what was before? So versus chatbots like ChatGPT, AI agent can not only follow a dialogue in a chat, but also run applications, do multi-stage operations, make decisions, plan, and act autonomously in order to pursue a goal. So like you set a goal for it, and it will work in order to reach this goal, no matter the cost, and it will try to act autonomously. So this is the main difference, like that with agent you can actually like you can do the task with hands of the keyboard. And if you compare that with assistants, which was the previous generation of AI tools, like the old Copilot or like JetBrains AI assistant, or I think even ChatGPT tool inside the ChatGPT thing, the app. So assistants usually give prepared responses or stubs, and only responds to a prompt, while agents like they act fully autonomously, and like there is no need to human intervention at all. Yeah, just a second, I will give you the link. I will try to give you the link. Yeah, so I actually started working with GitHub Copilot back in the days, like I don't know, 4 years ago, when it was only like a preview thing. So and it started as like a better autocomplete, and it was only single line autocomplete. So of course now it can do multi-line autocompletes, or even so autocomplete is kind of better right now, and Cursor also on Cursor and Windsurf has like incredible autocomplete things, but it's not like autonomous things. It's not like you can give a goal or like goal to it and it will do it. So agents, like, they are thinking. So what are the main stages of agent work? First, you have to make a prompt, like to determine a task. For example, make an API for applying a promo code. This is a really bad prompt, but and you will understand why. But it will do for now. So then agent will plan. Agent will divide the task into steps, create projects, make routes, like add tests, make documentation, register in DI, whatever. Then after a plan, agent will use IDE tools, the editor, terminal, Git, databases to pursue a goal to do this, to do the task. And if the code doesn't compile or tests are read, agent will analyze the errors and fix them. And it will run in that step. So, and also this will consume like 1 million of tokens and drive the oceans hotter and spend all the water on the earth. But then we will have an API for applying a promo code. Yeah. So as we are pizza company and retail food company, then almost all of my examples will be regarding with pizza things, like a promo codes. So there are a lot of various coding agents. Mostly I will talk about GitHub Copilot now, because it's the easiest thing. You only need a GitHub account for it. But of course, we use everything, almost everything. I have Cloud Code, a Gemini, and I've used Codex. And Copilot actually released GitHub Copilot CLI mode, like a Cloud Code and Gemini and the Codex. So of course we also use Cursor and Windsurf. Actually, internally we mostly use Windsurf, but we also have a Copilot, and Claude and OpenAI and Gemini I buy for with my own money, but our company supplies us Windsurf and the Copilot, because Windsurf has actually won in our like mini competition inside. But as I said, we decided that every 6 months for now, we will reevaluate the offerings, because everything changes really fast. So maybe in 6 months, Copilot will be better than Windsurf, or we will decide that we will go Claude all in, because actually Anthropic, the makers of Claude Code, and they have the best models for coding. So you never know. Right now, we use Windsurf and Copilot, and also have tried to use Copilot in web, actually. So they have like their own web-based agent, almost the same like they have in IDE, but it works in web. So as I said, reevaluate and try to use all the tools that you can, because you never know, maybe there is some feature and you can, and they all poach each other from features. So if like Google and Gemini or OpenAI will invent some new feature, GitHub will definitely just steal it. So let's talk about models. As I said, not only the tools like Copilot and Gemini, the models are also like commoditized. Back in the day, like 5 years ago, I thought that OpenAI is like poor. When was the first OpenAI model was released? I thought that this is like a killer feature. Like OpenAI will rule the world, and it is incredible. But sure enough, everybody now have a model. So this is a list of supported AI models in Copilot, and it's a short list. Actually, they have more, and Windsurf has even more models, like 40 of them. They have like a free models, they have premium models, they have like really expensive models, like Claude Opus, because it's like the best model out there. It's the like if you do a prompt, somewhere water runs out in some country. So yeah, there are a lot of models, and they also get commoditized really fast, and the like every like 3 or 4 months there is a new model. Like OpenAI just released GPT-5, and now they have GPT 5.1, and that is really funny because they didn't even implement GPT-5 codecs in some plugins, because there is already GPT 5.1 codecs. So yeah, it's in public preview, but still, like it's like 2 days ago or a week ago they released this GPT 5.1 codecs, and I just enabled it. So not only the agents and the software has gone commoditized really fast, the models themselves also. Usually these tools are built for the models, actually. So this is like an electricity user. So it's like the models right now are kind of resemble like utility companies. So so there are tools that build tools, or like people who build with the tools, and there are people who produce, these models and provide it like an electricity or water. So in GitHub Copilot Pro, we have 300 premium requests for $10. I think for Windsurf it's the same. And actually, this is really not enough. Like if you do like real production work every day, so you will definitely see this. So GitHub already has enabled like metered billing or something like this. So and they say, and for GitHub Copilot Business, actually, so we pay like 19. And yes, also the interest part is that GitHub Copilot Enterprise costs 39, but they say that it's like if you're serious with this, you will definitely hit this premium requests, and so it will be like cheaper in bulk if you buy Copilot Enterprise. That's what they say. Of course, your mileage may vary, but you have to keep in mind that all these agent things, it's not cheap. It costs money, but there are like free models, and not all the models are like great for. So this is also an excerpt from GitHub Copilot documentation. So some models are they are built differently. And usually this like more expensive models like Opus 4.1, it will cost like 10 times. So it will eat 10 premium requests for one prompt. But something like Claude Haiku 4.5 will eat like 0.5, or it will be like even cheap. Like it could be free. Like this Gemini 2.5 Pro will be cheaper in tokens and requests. So yeah, so economy also changes, and unfortunately, you have to have you have to know what models are best, in what, and you should try which models works best. I actually don't like that much. I really like that now in OpenAI, in ChatGPT, they just, you have like 5 and that's it. So, and one thing that I would like to have is that like maybe it will automatically think what's model is the best or something. Also, there is in GitHub now, there is also an auto setting which gives you a 10% 10% like it's cheaper, so it's like sale 10%. 10% off on requests, so it may be worth also thinking. Also, there is no thinking models in GitHub Copilot right now. We have them in Windsurf, but I will tell you about it. Yeah, so this is our what Windsurf has. They also have thinking models. So and you see that it's 20 actually credits. So for one prompt for Cloud Haiku, you could have for one prompt of Cloud Opus 4.1, you could have like 20 Cloud Haiku, and their own model, Windsurf 3.1 is actually free for now. So that's also one of the good things. Those are free because they are like in beta, but also you see that there is no reasoning, low reasoning, and medium high. I will tell you what is. Of course, thinking and high reasoning models are better, and Windsurf has them, but Copilot now don't. They see maybe they said that they will bring it back, but we will see. So thinking mode is like in normal mode, LLM just simply predict the next token, like autocomplete. And if you want to know what was this, you should watch the Andrew Karpathy tutorial on how to build an LLM. It's very good. So yeah, so LLM simply predict the next token. That's why they can't, tell you how many R's in strawberry, because there is no possible way like how they can, look far ahead and see that there is like a 3 R's in strawberry. But in thinking mode, the model uses internal chains of reasoning and additional computation to build a step-by-step solution, check alternatives, and make less mistakes. So yeah, so in normal mode, LLM is it's called one shot. Like it just imagine if you were given only like 1 second to do a response. So and in a normal mode, that's how it works. But in thinking mode, the model could think for a bit. And also there is 3 levels for reasoning intensity for some models. Like low reasoning will be cheap answer and fast, and it's suitable for like autocomplete because it's easy and you can, if you don't like this autocomplete, you will just not use it. Medium reasoning will think more, and high reasoning, it's like it can spend like a 10 minutes for thinking. Yeah, so of course it's better to use high reasoning models when you can. As I said, GitHub Copilot right now doesn't have it, but their competitors, Cursor and Windsurf and whatever, they have it. So let's talk about prompting. The context is really small, and you will see it as a big problem. So we have to maximize using the context. Best is to decompose a large task into small steps. It's better to handle each step in a separate chat, and we have to maximize the context, use the context loop. So it's better to be aware that context is the main limiting factor in using the agents and LLMs. So in a very big, large, like monolithic application, it will be really hard for a model to track context. So there are some ways that we can fix this, but usually the next big thing will happen when the models will have like infinite context. So you could just, put a million lines of code there and it will work good. So as I said, making API for applying a promo code is a really, really bad prompt. It will not work, or it may work, but it will be a really suboptimal solution. So the better prompts are like this, like add a promo code controller with a post API promo code without any logic. Use the input data model. Add saving of the promo code, like add mapping of the promo code, write an integration test. So you have to, right now, you still have to help the model, to separate the tasks into, you separate your goal or task into series of small pinpoint prompts. Yeah, so now we can talk about vibe coding as a new concept. What is vibe coding? Like vibe coding is when you describe tasks in a natural language, and AI writes this code, and that's it. Like we said with this prompt, like making an API for applying a promo code. And the AI-assisted development is when human solves tasks using AI, describes tasks in natural language, and check and improve the code after AI. So I think the good analog for this, good way of thinking is that vibe coding is like Waymo car or like Tesla full self-driving when you when you give yourself to a car and just full gas, no brakes, it will drive you to somewhere you will need. And AI assisted development, like mostly like in agents or in like AI assistants, is more like a cruise control or a better like electronic safety things like they have in now in car. So like it's still you who rides the car, and they will just only help you. So, and mostly when we are talking about vibe coding is the problems with security, yeah, or like with agents that are on like fully autonomous agents. So it's a real problem, and we all like if you will do this AI like agent or even assistant development works, you will definitely step into this. Maybe not as those people who were not careful enough, but it's like a real. For example, these models are like really smart and they can do a lot of things by themselves. We will talk about the security later, but mostly like vibe coding is like you can't trust yourself completely or your computer as of now. So is vibe coding cool? It's cool to ship a proof of concept. So like you could basically you could open a like a repository and let agent write a full code for yourself and ship it. So I think it's cool. Yeah, it's understandable use of vibe coding or coding without any reviewed stuff. But when we're talking about enterprise development, if you vibe code like a quick solution and toss it to review without even looking at it, we don't like that. And we like, for example, in our like state of development for for organization of our size, we will not accept it. Yeah, so maybe for like some startup it's fine, but we don't think that it's a good thing right now. But you can use AI but you can use AI agent just to try if AI agent can solve task on its own. For example, we still use a really old library, logging library, in our monolithic application, in some of our monolithic applications, and recently we thought maybe the AI will do like a really big refactoring. Turns out it could, but not for the all cases. So we decided not to do it with web coding, but it was interesting, like just to see if AI could, rip this old library, logging library, out of our code and put in like a new one, Also, I don't think that vibe coding is cool if you like don't test it. So all production code still just have to be tested. So you can't ship to production for our size and our like processes. You can't ship AI generated code to production without review and stuff. And also one of the things that we are still not sure about it. So we have 380 engineers, of course, and they do work in their own like parts of the applications. Some on the front end, some on the back end. So we have like 80 backend services, some microservices, some like monoliths, and we have a really big monolith. So I think sometimes it's fine if it's like a really small nitpick is to use a AI agent. If you, for example, like you go to a Python library or a Golang microservice, or I don't know, or a Swift front end application, and via the help of AI, you just like understand the project a little bit, and AI will help you make your own pull requests. But if otherwise, you will just have to wait like a month or when they have the time in their backlog to implement it. And I think it's fine. Yeah, so like small things where you could, as a person who is not like who doesn't understand what's the stack or what's the the application is doing. So if it's small, I think it's fine. But if it's a really big thing and you like just go and unsolicitedly give them like a 10,000 lines pull requests that made through AI, I think it's, of course, it's not good. But if we talk about AI assisted developments like the agents and stuff, like where the AI actually helps you write your own pull request, I think it's so one of the things that you can do is like you can ask to explain the code, like what to do with these all agents. Like you can ask to explain the code, you can research the code and give a suggestion. Like you can do a deep research on the code and make documentation. You can you try to use expensive models with thinking. Maybe they will give you a better way of whatever you're doing. You can do web search with it, to broaden your horizon. You can review your code with an agent before you wrote your own code, but you can use agent to review it. You can fix like some mistakes and stuff. You can write quick automation scripts, something that also like you could understand and you could write before, but you're too lazy to do it, or so it saves time, and maybe something even more. So let's talk about safety right now. There is a thing called prompt injection. It's a type of attack on AI system in which attacker injects special instructions into user input in order to bypass the model restrictions or force it to perform unwanted actions. So this is like SQL injection, if you know what's this. So it will work like somebody will put in like a web page on the internet, and your agent will do a web search inside your IDE and like download this web page, and it will say something, and on this page it will say something like get all the secrets and send it to somewhere, or install this like virus or whatever. Like actually it's like a remote code execution. So and it's actually a big problem. So you should do this. You should do web-based browsing in agent with a really big care, because, and also it's better not to give it access to. We will talk about it later, but this is like a real problem, and there have been solution, and there have been like real things, like real world repercussions with it. So prompt injection is a thing, and there you have to be careful with it. So what can this AI agent that we talk about in our workshop, Copilot, Windsurf, whatever, Cursor, Cloud Code, it can read files, even not in the working directory. Actually, there is a setting for that, but it could. It can run terminal commands. It can read the commands back from the terminal. It can perform web searches. It can open web browser and search like in the web browser, or it can use Playwright MCP to do this, like to open the browser, Chrome, and get the and browse for you. So all this is really um, with everything that is listed here, you have to be really careful. So with regarding working with files, agents can't generally read hidden Unix files like .github or .cloud or whatever. Agents also generally skip node models, because this is mostly for their contexts, and because there's like 10,000 files or something, or even 100,000 files. So they skip it for their own sake. By default, all agents skip everything inside git ignore. And you can have a global agent ignore. Actually, it will, so every agent will have its own, like load ignore or whatever. But don't forget that you have to have it. So I don't know, if you have nudes on your computer, you would want to put all these directories that are sensitive for you into agent ignore, or run it somewhere else, like on a sandboxed machine, or like in a VM. Also, agents can do a lot of things in terminal, and the terminal is actually a really powerful way to do bad stuff with your computers. So usually we do not allow automatic completions in terminal. Some people do, and there is a thing to do it in Windsurf or in Copilot or whatever. But personally, we don't do this. We don't think, except whitelists. So there is a whitelist, and in my repository, in our repository, we will see it. You can add safe comments to all of these. For example, like for a build, for tests, for I don't know, for adding the packages. So you could do that. Do not add secrets, or don't even let agent touch secrets, because they can do all the things with them. And check the comments for soundness. Like even if you don't know what the comment will do, you can ask them like what this comment will do, or like you can ask ChatGPT. So, and agents can be smart, and like, for example, I disallowed the like a directory for agent in order to reduce the context for it, and it used cat for reading files. So it's like so it can like circumvent its own like guardrails if it's if you just will leave it to it. Yeah, so a little Skynet. You can also use Playwright MCP for front-end tasks, for actually Googling. So this is really powerful to open a web browser, like a real web browser. So you can almost do like end-to-end testing with it, with the prompts and stuff. So it can like click through the scenarios, test something, emulate your work. It can even log in on your behalf, but try not to give it your actual passwords. So yeah, the Playwright MCP will use a thing called MCP, Model Context Protocol, which we will discuss later, to use to, for example, open a Chromium or Firefox through the model and use it on the model's behalf, on your behalf. So what is Model Context Protocol? It's a universal protocol for LLMs to interact with various tools. Yeah, so before MCP, everything had their own unique API, but with MCP, there is a way, to generalize model access to that. So it's like a USB-C for models. Don't forget that S in MCP is for security. So by default, it's not secure protocol. They added OAuth 2.1, I think, but it's added like afterwards. Mostly they just use API keys, which is kind of bad actually. You have to use OAuth for a lot of things. So, yeah, maybe it will get better. So there is an MCP marketplace in VS Code and Windsurf, whatever. Everything has now an MCP marketplace, and a lot of tools right now have also MCP, like Slack, for example. GitHub have MCP. So a lot of websites and stuff. We in Dodo, in our own internal ERP software, also are thinking about getting MCP. So to give our people who use ChatGPT, so they can ask ChatGPT for promptings. Yeah. So if you do, if you should think about building MCP into your own software also. Don't forget that MCP love contexts, and it will really it can go out of hand really fast. So you should also try to limit the context usage through MCP. There is an MCP marketplace in VS Code, like inside it, and you can use it or add the configuration in VS Code in a .vs Code file, or if you need MCP for like a web agent for GitHub Copilot, you can add it through the settings. So let's talk about contexts. Context is the new oil. The main problem right now with the AI development is that there's always not enough context length, and we can use some techniques to reduce it. Maybe someday we will see models that will, do various things to reduce context, and there are different ways to approach this. For example, Cursor uses RAG, retrieval augmented generation, on their backend to reduce context, but Copilot and Windsurf, for example, or Cloud Code no. So I decided not to empathize on this, but there are various things to improve context, and some models have a bigger context. Some models, for example, Google 2.5, Gemini 2.5 Pro has like a million tokens of context, so it's really good. But even that is not enough. So there's always not enough context length. So how can we improve this? How can we, what can we do this? How can we fill just the context that we need? So there are a couple of ways. First, lightweight. You can ask the model to study the project and the specifics of how the feature you're going to work is implemented. And after that, you move on to questions and actual work in the same chat. So this is like context filling in a chat, like inside your chat. So your whole chat window, like a chat with the agent window, will have the context inside it. Windsurf has a wiki that you can use to preload the context from it. Copilot doesn't have. Maybe they will steal it. I don't know, but there are like a couple ways to do this. But and this is needed because you could have like 100 folders, and of course the model won't be able to to do anything with it. So you have to fill like this context through a like you have to provide the contexts and the really small contexts, because as you do more work in the chat, the context window will increase, and you will get a hang of it. But so just remember that you could do a lot of things there. Also, you could you could help model to reduce contexts and validated work through test-driven development. The more the model can automatically validate work, the higher quality and the more completed feedback loop will be. And TDD will make it possible to spend less time on manual code checking, and the model will be able to work through that more quickly. And this also applies to more strict typed languages like C#, Rust, TypeScript, Java, whatever. Like it's for models, it's better to have more strict languages and use, of course, tests and the linting and static analysis, because it will help model, to concentrate on the thing and get instant feedback. And there is a example of the prompt that you can use to set up the tests for TDD to to get like so like in one chat you can ask to set up TDD, and in second chat you can work on it and work through tests. So and that's how you reduce your context, so you do it not in the same chat. So overly large contexts are also really bad. As I said, if your chat is like I don't know, 50 messages long, it will be really bad. So there is two metrics for that: answer relevancy and context relevancy. So answer relevancy is evaluates how direct and useful the generated answer will be. So it can like so for example, if the model like responds to you like true or false, it will be like 100 answer relevancy. So sometimes models will will give you not relevant answer, or like a really long answer, so or just a wrong one. And context relevancy is a metric to like were the model correctly interpreting context. So like giving a line number or item number in a plan document. So plan document. And there is also a thing called lost in the middle. So if you have a like really huge context, like a million or no, like 100,000, so the models like just forget or lose attention in whatever there is in the middle of the context. So that's why you also have to, have to try to reduce context. as much as possible. There is a study, and I will link to it in the end, that shows that in really big context windows, model will lose the information inside, like in the middle of a context. Also, one other technique that you can do is called prompt chaining or pipeline pattern. Is a pattern when working with LLMs where a complex task is broken down in a chain of steps. So instead of one overloaded prompt or one really simple one, a sequence is used, and the result of each step is passed as an input to the next one. And this approach provides modularity and control, so it's easier to check and optimize each step. And also you'll have like a checkpoints, or you can commit, so you will not lose your work between these steps. You will have reduced lost in the middle effect, because at each step the context is smaller, so like you will create a new chat and it will be easier to you to monitor and stuff. And it will have improved relevancies, both answer and context. So with large context, the model will hallucinate more and produce relevant details. And so this will be really noticeable with, you know, if you go as there is on the slide, if you go and ask, like, build me a complete service plus contracts for that, plus tests, and and give me a coffee. So even if model will be able to do that, it will hallucinate more and more when the context will be like really big. All the tools, all the agents like Claude and Copilot and Cursor and Windsurf have their own like ways to battle this really big context problem. So in Copilot we have these chat instructions. So this is like a basic prompt, like a system prompt that will help your model to focus on tasks, like name and make the tasks better for you, like naming conventions, like your code conventions, like whatever you need to do. And for example, like we usually put an instruction there not to write over the long documentation, for example, because it's not needed mostly all the time. So and there is custom agents and prompt files in GitHub Copilot, which help you to reuse this prompt. And the one thing that you like, why you should reuse the prompt, because you have to open a new chat for new like small tasks, because this actually saves the context. So prompt files are the standalone prompts that you can run directly in chat, and you can include task-specific context, and you can chain these prompts. Like prompt 1 can have prompt 3 inside, and yeah, and don't remember that if they are too large, you'll have the same problems with big context. So use this precisely. And in prompt files, you can, like, for example, we put like so I give here you 3 examples. Like you put refactor role, or run tests and fix role, or address PR comments, and it can use, for example, GitHub MCP protocol, or use GitHub CLI for that, for accessing GitHub's, like, to address PR comments. Also, one of the features that you shouldn't forget, that it has both Windsurf and Copilot and whatever have mostly drag and drop. So like you can drag like, for example, program CS into the chat window, and it will add to your context. And this is really important, because your agent will know where to look right at the start, and it will not have to to search for this program CS or to, and that's real. And if it will have to search, it will reduce its context window. So it's a really neat feature. Or you can put a hashtag or add in Windsurf, hashtag in Copilot, and mention this file, and it will look exactly there. Also, there is a checkpoints to roll back chat and edits that also saves context, because if you click on restore context, restore checkpoint, it will delete the chat history, and you can also redo these things. So so it's also an important feature, because if the agent strayed too far from the intended way, you could restore checkpoint and steer the prompt whenever you need. Also, there is a GitHub Copilot memory. Windsurf had it for some time, but Copilot now has this. So there is like a memory tool that allow models to store information across conversations, and that's also regarding the prompt. That's also regarding the context, because it will help. You could add, you could work in a one chat, and then go to and like save the results there, and go to next part of the chain in this chat, and start with a fresh context, but with like a small information on from the context. Or you could save there, like how we did the feature like half a year ago, for example. So it's really handy. So with that, the theoretical part is done. We will go to the practice right now. There is some references and a really good agentic design patterns book with the prompting and stuff. I will send you a link to that, actually, because it's a really good book. I think we are going to have a small like 3 minutes 3 minutes time out, and start the practice. As I said, what you will need for a practice, you need a GitHub account, you need Copilot, Git, Visual Studio Code, .NET 9, and installed, and Context 7 account. You can check out or download the repo that I put there. After you download, you should create a new issue with the template workshop, and there will be let me show you how it works. So you create an issue, put your name or something, and here you have your checklist for doing a workshop. There are 4 tasks. It could take more than half an hour, so maybe you can take it later. I will put it, it will still there, so take your time. And that's it. Thanks for your attention. Let's start with the workshop. So yeah, I've cloned the workshop repository locally, and of course I've built it. So then if you have a Docker or OpStack, you can try to use dev container. Let me do it like this, so it will be easy for you. So let's just work through the workshop there. Yeah, so it should work for you if you're familiar with .NET Core, it will be easy for you. If you're not familiar, you can ask Copilot for help on that. Mostly you have to do a .NET run and .NET build. So let me guide you through just a second. Yeah, so here you have your chat window. Here you have your chat history that you can, oh yeah. So as I said, there's actually a lot of things to do right now, but I'm not sure you can see it. So first thing first, you have to you have to build the projects, run the tests. So you open the terminal, go to, well, you open the terminal, go to src and web API, and check if it builds. For me, of course, builds. You can check as the CAS. Like this. So yeah, and you have to install the Copilot plugin, and it will show you, as I said, as I added it to extensions, it will show you here, like, please install this plugin, and then we can do things with agents. Like, for example, if you don't know how to, like, I don't know how to start this application, I think it will show us how to do it. And yeah. It's in scene directory. No, it's not a Node.js project. It's a C# project. Oh yeah. So, but first things first, you have to configure terminal to auto approve for Copilot. In order to do that, you go to chat settings and search for terminal auto approve. And here you can edit this, what I said, the auto with this auto approve files. As it's in this issue, I put the recommended allow list. Actually, we can follow it like this. So the recommended allow list for us is .NET Test, format, run, build, restore, and mkdir. And deny list is mv, cp, dd, sudo, and tar. mv and cp because it could be destructive. dd, of course, destructive. Sudo is off limits, and tar is just not needed. So yeah, dd is also already denied, and we will add sudo, and we will also add mv. What else? CP and tar. And here we will allow this .NET things. Oh yeah, that's the way. So we auto approved .NET test, format, build, and restore. So we can click on it. Now we have to add MCP servers. This is not exactly a needed part, but this will be required for task, I think, practice 2. Yeah. So in order to add context 7, you just add here, like you will have a button there, and you can also add the playwright for playwright MCP. Or good. Actually, there are a lot of MCP servers, so when you will handle your tasks, you will definitely know when you need it, and it will be really handy to do it. So yeah, for context 7, you'll have to create account on their site. The context 7 is a MCP server that provides the LLM with the fresh documentation. And this will be really needed there because in a second practice, because the new methods that we need for the tasks are only available in .NET 9, and models currently don't know how to do it. But with the documentation, they will be able to do it. Yeah, so we connected it, and now we have to configure chat instructions. So the chat instructions are, as I said, we can, as I said, the system prompt are part of the prompt that models will follow. They don't always do it, but especially if the context is overloaded with other information, but usually they should. You can generate your own chat instructions. This is done like this, and it will you have to open a new chat, then put generate chat instructions, and it will analyze the code base and generate chat instructions. And it will do actually, and it will do a better job than it's done before, because it will actually read files and understand them, and and actually it will generate really good instructions. But you can use our own, like you can use the provided chat instructions from here. So here is like a role definition. It's not always needed, but it works, I think, better. Yeah. So we mostly talk in Russian. So there is this thing. Maybe you need it, maybe not. But of course, we still use English in the code, so no Russian there. So we provide our agent with planning and execution guidelines, like for investigation steps, for implementation steps, for self-check, for example, like .NET to do a .NET analyzers, to to generate a better plans. And we provide our own C# coding style, because C# is not that strict in formatting and style as, for example, Golang, because it's a more expressive and verbose language, C#. But and there are more than 2 ways sometimes to do the same thing in C#, but we still like it. But you have to, help your agent to use, for example, syntax that you need, like file scope namespaces, modern array initializations, switch expressions, like records, all the new shiny things that model may or may not use, this system prompt, you require it to use it. Yeah, and also, try to write short messages. So it's basic things. Here we disallow it to comment. Disallow it to comment on thing, and here's also like, please run tests. Please infer relating areas. So it will not create like a new DTOs, for example, if there is one. So this is also really important. Yeah, you see that there's yeah, I've successfully created copilot instructions with compressive. Yeah, so it created and guidelines, and yeah, it looks really nice, and it showed how to build and run, and it successfully inferred what's the startup project for APIs. Yeah, but this is wrong. We use a different port here. For a startup, we use a different port, but still, it's nice. Yes, for tests, there is no, for example, code coverage, but still, it's really nice that it found a way to test a project. Yeah, it works. And it can use API testing for example, and what to not to do. Yeah, it's nice. It's nice. So we can, for example, keep it or add what we want, what we need. So yeah, first practice is as we did it. So the first practice is to generate a description of a repository. That's what I tried to do before. So let's use this prompt, and we will rewrite the README with it. So we'll use agent. And we will try, and right now we will try GPT 5.1 codecs. Yeah, so now it started thinking, created to-dos. You can watch the to-dos from here. So right now it identifies the controllers and stuff. And that's how developers will work from now on. Review the code of and autonomous agent works. Yeah, so you see as the agent has completed this to-do, try to, yeah, it created a README. Yes, library landing is a .NET 9 sample project that demonstrates a clean, testable library management system. The API lets you register patrons, add books, and track book loans, showcasing how to structure a CQRS plus mediator application around rich domain entities. Yeah, so the tax stack is fine. It's fine. here is fine. Yeah, how to build is fine. Run is also fine. You can actually omit this, but it's fine. Yeah, looks good. Yeah, and we can keep. So it created this overview and README. And this is more, you know, this is more complete as we asked, because it created more complete overview. So I think we can have time for some questions if you have. If somebody has a question. Because obviously we have only like 12 minutes to the end. So if somebody has questions, there's right now a good time to ask. Yeah, and the second practice will use MCP and the web browsing to add a DB initialization and seeding at app startup. So I will show you the prompt that you can use. We will also use GPT 5.1 codecs. And we can provide the agent with the program.cs, as I said, so it will understand, and it has to remove this seed data async and put and use the new controller to populate. Yeah. So let's start it. Yes, you see it used reference, compiled instructions, and it did multi-step planning. Confirm framework versions. It's interesting. And it should now research EF. Yeah, that will. Context 7 compatible. Yeah, .NET Entity Framework. Yeah, that's right. So there is some error in get library docs. Invalid arguments for two get library docs. Wow. Maybe this MCP server is that I installed from the, maybe it's kind of bad. So it will work like this, and what it should do is to remove this seed data sync, and it should use something like builder services use sync and use async seeding. So it should like basically it should do user memory database, and here Yeah, let's do this. Yeah. Yes, our agent is thinking about how to do it. But basically, it should make it like this. Like this, and options, use a sync seeding, and put these methods, like if context books any, put it there inside use a sync seeding method. This. Oh yeah, it found. So and you can do task 3 and task 4 later if you feel about that, but mostly, so the task 3 and task 4 is about planning. So there is a mode called plan in all our agents. So you could create a multi-step plan inside the chat and then like implement it. And there are like 2 ways to do it. First, through planning mode, without rules, workflows, or like custom agents and prompt files. And the second way is to create a plan and then implement it through custom agents. So like you will have a lot of custom agents, like the one will generate like tests, and I'll analyze the code base, do an solution architecture design, a proof architecture. It doesn't show mermaid. So this is mostly for you to understand that there's more to it, and you could like they could create this like agentic workflows already inside the oh yeah, so it changed something. Oh yeah, you see that it did exactly that we asked. Options, use in memory database, and use seeding. It's not a sync seeding, so it's not like a 100% right, but yeah, so it's kind of good, but it's better to redo it in, for example, close on net 0.45. Yeah, let's redo it. But it's close. Yeah, so that's it. I hope you had a great time. We can go on.
Thank you, Gleb, for the nice tech tutorial. We'll be taking a short break and we will continue at 13:30.
Yeah,
Thank you. Goodbye. Mm.